Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on thermochemistry. Previously, we discussed work in relation to the concepts of thermodynamics. In today's lesson, we will discuss standard states, including the standard molar enthalpy of combustion, the standard molar enthalpy of formation, and the standard molar enthalpy of neutralization. Students, if you are ready, then we will begin. The standard state of a substance is a reference point that can be used to calculate its properties under different conditions. The standard state is most stable state of a substance at a temperature of 25 degrees Celsius and at normal atmospheric pressure. The standard enthalpy of combustion is the change in enthalpy that accompanies the combustion of 1 mole of a substance in oxygen at standard conditions. I am sure you remember that enthalpy is a measure of the total energy of a thermodynamic system at constant pressure. Many of the chemical reactions that produce heat are combustion reactions. For example, when we eat food, it gets combusted within our bodies. This process provides us with the energy that we need to perform daily activities. Carbohydrates and fats provide our bodies with most of the energy they need. Carbohydrates get decomposed within the intestines and become glucose. Glucose dissolves in blood and is referred to as blood sugar. Blood transports glucose to cells within our bodies where it reacts with oxygen to produce carbon dioxide, water, and energy. The standard enthalpy of formation is the change in enthalpy in the reaction when 1 mole of a substance is formed from the elements in their standard states. By its definition, the standard enthalpy of formation of the most stable form of any element is 0. Here you can see the standard enthalpies of formation of several substances at 25 degrees Celsius. Students, please define the terms standard state, standard enthalpy of combustion, and standard enthalpy of formation.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, everyone. The standard state is a reference point that can be used to calculate a substance's properties under different conditions. The standard enthalpy of combustion is the change in enthalpy that accompanies the combustion of 1 mole of a substance in oxygen at standard conditions. The standard enthalpy of formation is the change in enthalpy in the reaction when 1 mole of a substance is formed from the elements in their standard states. Great work, students! Let us continue our lesson by learning how we can use standard enthalpies of formation to figure out the standard enthalpy changes of chemical reactions. We can add the enthalpies of formation of all reaction products, taking care to multiply each molar enthalpy of formation by the coefficient of that substance in a balanced equation. From this, we can subtract a similar sum of the enthalpies of formation for the reactants. In this equation, N and M represent the stoichiometric coefficients of the chemical reaction. Let us calculate the standard enthalpy for the combustion of propane from the standard enthalpy of formation values of the products and reactants. We begin by writing the equation like this. We then list the standard enthalpy of formation value under the formula of each substance in the equation like this. We then add all of the enthalpies of formation of all the reaction products and reactants and multiply the molar enthalpy of formation by the coefficient of that substance. This equation simplifies to negative 2,324 minus negative 103.8, which gives us our final answer. Therefore, the standard enthalpy for the combustion of propane is negative 2,220 kilojoules. This type of calculation can be used to determine how much energy is available from the food we eat. The standard molar enthalpy of neutralization is the change in enthalpy when 1 mole of an acid or a base is completely neutralized. For example, this shows the heat of neutralization for hydrochloric acid and sodium hydroxide. Students, let us try an activity. 1.00 times 10 to the power of 2 milliliters of 0.5 molar hydrochloric acid was mixed with 1.00 times 10 to the power of 2 milliliters of 0.5 molar sodium hydroxide. The initial temperature of the hydrochloric acid and sodium hydroxide was 22.5 degrees Celsius. The final temperature of the mixed solution was 25.86 degrees Celsius. Calculate the heat change for the neutralization reaction on a molar basis?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did you do? If we assume that no heat has been lost to the surroundings of this system, we can use this equation. Q solution represents the heat that is absorbed by the combined solution. Since the density of the solution is 1.00 grams per milliliter, the mass of 100 milliliters of solution is 100 grams. Thus, we can use this equation and determine that the heat absorbed by the combined solution is equal to 2.81 kilojoules. Since the heat of the reaction is the negative of the equivalent to the heat absorbed by the combined solution, then the heat of the reaction is minus 2.81 kilojoules. The number of moles of both hydrochloric acid and sodium hydroxide in 1.00 times 10 to the power of 2 milliliters of solution is equal to 0.0500 moles. Thus, the heat of neutralization when 1.00 moles of hydrochloric acid react with 1.00 moles of sodium hydroxide is the heat absorbed by the combined solution divided by the number of moles of the acid or base in the combined solution. This gives us the answer minus 56.2 kilojoules. In today's lesson, we learned about standard states. In our next lesson, we will discuss entropy and spontaneous process. This is all for today. Until next time, thank you, teacher. Thank you, students.